We discussed already single variables. Curiously, it's not the major type of the variables used in R. If you go to the quick R tutorial, then you will see that they skip single variables and begin with the lists of the variables, which are called vectors. So don't confuse yourself. Every time a tutorial tells you about vectors, it doesn't mean something complicated and directional. It means they talk about lists of values. And again, it can be numeric, so can consist of the single numeric values. The style how you do it, you write letter C, then round brackets, then comma is the separator of all these single variables, 1, 2, 5.3, 6, minus 2, and 4, and then you close it with the round brackets. And it can be a vector of characters, so you can write it in words, 1, 2, 3. And of course it can be a logical vector, whether you test whether something comply to some conditions, true, false, and then some of them can be true, some can be false. And again, it's easier to do it in R Studio. So we can assign 1, 2, 3 to the variable a, and then again we can say what is the type of a. It says double. It doesn't change the variable type, whether it is list or a single variable. If it is a simple numeric range, you can always do it like this. Here, for instance, I say 1 to 6 is my range. And I also can ask what is my range. It's 1, 2, 3, 4, 5, 6. And you can also see it over here that in the memory it is already my range. R is famous for its vector programming, so it manipulates with the lists like it manipulates with a single number. And therefore, if you multiply my range by 2, it means every value in a range will be multiplied by 2. And here we have it. Logical. So logical is will appear if I say, for instance, my range is smaller than 4. And before that I will put it back to 1 to 6. I rerun line number 29. My range is now 1, 2, 3, 4, 5, 6. And then I say logical. I assign it to logical. My range is less than 4. And then it says true, 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 false, etc. Logical. True, 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 false, false, false. There is an interesting function called table, which simply counts elements in your vector variable. If I call table logical, then it says it is 3 times false and 3 times true. Nice, convenient. So there are some nasty effects caused by the fact that R is a vector programming. It doesn't like combination of different types of variables in one list, in one vector. So things like this is a nightmare in R, which should be avoided by all means. So if it is a one integer 2.1, which is a real number called double, it is okay. But if by accident you added a character variable to the same list, and then ask what is my other list, visually you see already that they come in quotation marks. And if you say what is a type of other list, then it says character. All of them are characters. And therefore, if you will try to do some operation like other list multiply or even plus 1, it will not work. Because if it is a character, math operation will be disabled. Don't do it. Usual problems in R scripts are related to incompatibility of data and functions. It is very often that if you have a problem, if some line is rejected, it's very likely that the format of the variable doesn't fit to the function you try to apply. The next type of the variable in quick R, for instance, is matrices. Matrices is a sort of a data table. When you see such description in the tutorial, you have to realize that it is actually working part of the script, so you can copy this stuff and paste in your R. So you better add immediately if you will save it. Say that it is from quick R, and then what it says that it simply takes a numeric range from 1 to 20 in a format of 5 rows and 4 columns, and this will be a table. When it happens, then you see this symbol of the spreadsheet. You can click on it, and then indeed you see how nicely all this numeric range is placed in the 4 columns. And you can also notice that the gray area, columns and rows, it is a place for row names and column names, which you can define yourself. You can say, for instance, row names y is c, of course it should be vector, a, not very original, but okay, b, c, d, oh, one more, e. It should be equal indeed, otherwise it will not work. And then you look, and here you have A, B, C, D, and the same way you can do column names. And you can also ask, what are my column names? and it will say there is nothing for column names, not assigned. Right. Back to our example, you can also generate a matrix from lists of already defined variables. You have my range, you have A, you have other list I would not take, letters is okay. Let's check. And the rest I can try to bind all together. So it will be normally distributed data with 5 each, then with average around 5 and standard deviation of 0.5. And now I generate my tables, my letters not yet. Because it's a low case and I want uppercase. So I define my letters, now I have all of them. It gives a warning. Why? Because number of the length of my vectors was different. And it is another strange thing that even if the length of my vectors is different, it is capable of merging together these three vectors into one table. But if you look into it, you will see that it is nicely 1, 2, 3, 4, 5 to 6 and up to F. And my list, oh yeah, and my list repeats the first value one more time because it was a 5 times only, and I have a 6. Now the column names are inherited already from my individual vectors, but the row names are not yet present, which you can assign again as saying um, row names, no mistakes. My table will be equal to, and I will use function paste. Something like, let's call it item, and then range 1 to 6, and then separator will be underscore. And now if I look into my table, you see item 1, 2, 3, 4, 5, 6, and my range and my letters. And for instance, if you want to know the value in a column of my list, you can call it by name, and then it will tell you, it will give you row names and give you the values in the column my list. You can also say column 1, it will go do the same, and column 2. And you can also say column 1 and 2. Then it is more like a table. It says my list, it's row names, my list, my range, and 2 columns. Or I can say give me first and the third column. I can do the same. It's first and the third. And if you have 2 numeric columns, it was 1 and 2, I suppose. Yes. I can do a plot. Plot is probably the first graphics you can do if you have a table and two numeric columns in it. So my list and my range, here we are. My range go first for X, and for Y it will be my list. Here the letter is both means draw me line and dots or points. Why not? And it better be zoomed, and if you zoom it, then it is your very first plot. It is a bit clumsy. You still have to write title to it, and probably you have to work on this, but already many things are available and the quality is good. And it belongs to a category of basic plots because they sit in a base of the R. You can also ask a question, plot, and it will say default scatter plot function in package graphics in a package base in library. So base means that what you have right after installation of R. And the very last variable for today is a data frame. Visually, you can simply declare my table, which you have already before. You declare that it's not a matrix variable. Oh, actually, I forgot to ask what is the type of my table. Character, because remember, one column is a character. What is the class is a matrix and array. And if you do data frame and ask what is data frame, yeah, it's still the same table, looks like. But if you ask what's the class df, and df is a standard abbreviation for data frame, it says it is a data frame. So the type is changed, although visually it's still the same thing. What is different here, although, that you can refer to the columns differently. You can refer the same way, but also differently. You can use dollar symbol to refer to the columns, which is quite useful. And next to this visual feature, you have to realize that many functions are very selective to what they like to see. Some functions like to see your data as a data frame, and some others like to see it as a matrix. And depending on the situation, you can convert your data into the data frame from matrix or into matrix from data frame simply by declaring back and forth what kind of variable it will be. For instance, you can say my matrix is as matrix df, and then you generate my matrix, which is identical to my table, where dollar symbol will not work anymore, but other functions will work. In order to create a data frame, you don't have to make matrix first. You can declare it directly using a function data frame where you uh, mentioned all the vectors you used before and row names, and if you click, uh, it will say OK. Provided that you corrected my list, remember it was length of 5, but now you have to redefine it as a length of 6, otherwise it will not work. And how it looks okay. It looks that row names are here as declared and column names are inherited from the names of the vectors. And that's it for now for here.